Section 4.6 is on applying the exponent laws. So the exponent laws you've done in junior high. In grade 9 you went through some of them. So we'll just review those. Product of the powers, if you have something, two power terms being multiplied with the same base, then you can add the exponents. And the second one, quotients of powers. If you have two terms being divided by each other with the same base, you can subtract the exponents. And the restriction there that the base cannot be 0, because then you would be dividing by 0. If you have a power of a power, then you multiply the exponents. If you have a power of a product, then that power can come inside to both terms. So you could bring it into the b and to the a. So basically a gets raised to the power of m and b gets raised to the power of m. Power of a quotient basically means that if you have a quotient raised to a power, then you can take the numerator and raise it to that power and take the denominator and raise it to that power. Again, restriction that b cannot be 0, because if b was 0, then you'd be dividing by 0, which is an undefined number. The 0 property, anything raised to the power of 0 is 1. And negative exponents, anything raised to a negative exponent can be thought of as the reciprocal of the base raised to the positive exponent. And when that reciprocal has a 1 in the numerator, then you can just simplify that to 1 over a to the n, because 1 to the n is always 1. All right, so let's take a look at some examples of how we can use these rules. So the first one, set of examples here, is basically using your product of powers rule. So if you have two power terms with the same base, the rule is you can add the exponents. And if you think about that, 2 squared is like 2 times 2. 2 cubed is 2 times 2 times 2. So if you put all those together, there's 5 2's being multiplied by each other. So the answer is 2 to the 2 plus 3, or 2 to the 5. And x to the 3 times x to the 5 would be the same as x to the 3 plus 5, or x to the 8th. X to the 4 times x to the 6 would be equal to x to the 4 plus 2, which is x to the 6th. The next one, t to the 3 times t to the 6 would be t to the 3 plus 6 would be t to the 9. And the last one here involves a couple of different rules here, but basically you have 5 gets multiplied by the 3 to give you 15. And then you'd have 2 powers of x, because when you're multiplying a product of things, you can change the order, and you will still get the same answer. So x squared and x cubed can be put together to be x to the 2 plus 3, and y to the 4 plus 2, which would give you 15 x to the 5, y to the 6. In the second set of examples there, we have the quotient of powers rule. So I like to do this one a lot of times by writing it as a quotient like that. You don't have to do that, but because then you can kind of look at it as terms of cancelling, like 2 of these 2's in the bottom can cancel with 2 of the 2's that are in the top, leaving you with 2 to the 7 minus 2, or 2 to the 5. I'm just going to try that again. That looks a bit. So that would be 2 to the 7 minus 2, or 2 to the 5, which is 32. And the next one, again, you can think of that as cancelling or subtract your exponents. Or you can think of it as cancelling, like those 3 x's in the bottom can cancel out the 3 x's in the top, leaving you with x squared. And this one, I prefer to write it as a quotient. You can use the subtraction rule if you want, but again, I like to look at these ones as cancelling out. I always make silly mistakes when I'm subtracting exponents. So I would cancel out 3 of those x's in the top with 3 in the bottom, which would leave me with 1 over x to the 5. Or you can think of that using your subtraction rule as 3 take away 8, which is x to the negative 5, which would be written as 1 over x to the 5, because a simplified expression should not have any negative exponents. The next one, there's a couple of ways you can do that one as well. You can do the 4 goes into the 12 3 times, and then you can say x to the 2 minus a negative 3 if you wish, which would be 3 x to the 2 plus 3, which would be 5. The other way you could do that one is to take the, well, 4 goes into the 12 3 times, but then anything that's a negative exponent in a denominator, provided it's not added or subtracting to something, could be brought up in the top as x, that x to the negative 3, in other words, could be brought up in the top as x to the positive 3. And if, by the same reasoning, if there was a negative exponent in the top, provided it's not attached to something else with a plus or minus, that negative exponent in the top could be moved down below, because the reciprocal of something that's in the top of a numerator will end up going in the denominator as that same base but to a positive exponent. So you could do that as well and then cancel it like we did over in the earlier questions. The next one there, I would just, and again I like to cancel, but you can use the subtraction rule if you want. I would put 8 goes into 16 2 times, and then I would kind of think of this as cancelling. You've got x cubed and x to the 5 in the bottom, so that three of those x's in the top would cancel out 3 in the bottom, leaving with only x squared in the bottom. And then y to the 4 would cancel in the top, leaving with only y cubed. Because there'd be 4 y's multiplied by each other in the bottom, 7 multiplied by each other in the top, so those 4 y's would cancel out 4 of the y's in the top, leaving with only y times y times y. So if you put that all together, you'd have 2y cubed in the top over x squared. And the last row here, you're using the power of a product rule for the first one. So that would be, this power can come inside to each, if there's things multiplied or divided inside of brackets, you can bring the power outside to each part. So this would become 3 squared x squared, which would become 9x squared. So that would be our answer, 9x squared. This one here, it's a power of a quotient, so that means that each part of that quotient, the numerator and denominator, can both be raised to the power of 3, 2 to the 3 over 3 to the 3, which would become 8 over 27. And the next one, you've got power of a product again. So all those things inside the bracket are being multiplied, but they're all being raised to the power of 2. So that means you can bring that power into each part of that product. So 5 gets squared, x cubed gets squared, and the y to the 4 gets squared. And that would give you 25. And now you have to use your power of a power rule, so that would mean you'd multiply those exponents. And this would be y to the 8. And if you think about it, sometimes people get confused whether or not they're supposed to multiply those exponents there or add, but just think about what that means. X cubed squared, that means x cubed times itself. So you've got x cubed times x cubed, which is basically x times x times x times x times x times x. So there'd be 6 x's, so therefore you'd multiply. So 25 x to the 6, y to the 8th. And the next example requires you to use a couple of different rules again. So the first thing I see there is the power of a quotient, and first I would probably get rid of that negative exponent. So negative in the exponent means flip the base. So I'm going to flip that base, put the 4y to the 5th in the top and 3x squared in the bottom. And then I'm going to raise it to the power of positive 2. Don't really have enough room here to do all what I need to do. And then I'd have 4 squared y to the 10th in the top, because I'm going to bring that 2 into both parts. And then I'm going to have 3 squared x squared squared, which is x to the 4. So I'm going to multiply those powers. So that's going to leave me with 16 in the top, y to the 10th, over 9 x to the 4. And there's no common factors for 9 and 16, and there's no common factors for the powers of y and the powers of x. So that would be finished. The next one there, I would have to do that power of a product first, so that would become 3 squared, and x to the 5th squared, which would be x to the 10th, because you have to multiply those powers. Then you'd have y to the 4th, over, this would be 2xy, not much you can do with that yet. So then that would become 9 and these x's can cancel. This x can cancel out that x, one of the x's up here, leaving you with x to the 9. And this y can cancel out one of these y's up here, leaving you with y to the 3. So you would have left on top 9x to the 9, y cubed, over 2. The next property is pretty easy, because anything raised to the power of 0 is 1. So this would be 1. Let me just fill that in down here. This would be 1. This would be 1. This would be 1. This would be a little bit trickier, because this means negative of 3 to the 0. So that's the negative of 1. This would be the whole thing in brackets is raised to the 0. So if there's a bracket surrounding that power of 0, applies to everything in the bracket. So that means that whole thing is raised to the power of 0. So the whole thing would be 1. But here, when it's written like this, that 5 is not raised to that power of 0. That 5 is separate from the x to the 0. So that would be 5 times 1, or 5. All right, so G says simplify using the negative exponent rule. So we've got 3 to the negative 2 would become, and again, you can skip this step if you want. I always say reciprocal of the base to the positive exponent, because then it helps you remember when you have things like D and E what to do. But some people skip that step when it's a whole number or integer, and they just write it as 1 over 3 squared, or 1/9. 5 to the negative 2 would be, negative in the exponent means reciprocal of the base to the positive exponent, which would be 1 over 5 squared, or 1 over 25. X to the negative 4, not a whole lot you can do with that. That would be 1 over x to the 4, which is 1 over x to the 4. Or just like that. You just can't do anything more than that. So negative in the exponent again for D would mean flip the base, which is 4 over 1, or just 4, to the positive 1/2. And 4 over 1 is 4, and positive 1/2 means square root. Okay, remember a few days ago we did the rule where we had the nth root of B meant B to the 1 over n. So that would equal 2. Negative in the exponent means flip the base, so that would be 4 over 3 to the positive 2, which would be 4 squared, or 16, over 9. Don't really need to write that twice. I'm just going to write that in the box there. So that would be 4 squared, which is 16, over 3 squared, which is 9. Next question is, again, negative exponents. So negative in the exponent means flip the base. So 16 over 9 to the power of positive 3 over 2. And then that means the square root of 16 over 9 all cubed, which is going to be 4 over 3 all cubed, which will equal 4 cubed over 3 cubed, or 64 over 27. And the last one there is the cube root of 8x to the negative 12. Now that one's a little bit trickier. Again, there's a couple of ways you can do it. Probably, I might look at that as, separate that as the cube root of 8 times the cube root of x to the negative 12. And again, there's more than one way to do this. And the cube root of 8 I can replace with 2. And then the cube root of x to the negative 12, I would probably go back and write that as x to the negative 12 all to the 1/3, using your exponents of exponent of a third for the cube root. So then that would equal 2x to the negative 12 over 3, which is going to be negative 4. So then that would be 2x to the negative 4, which you can't leave the negative exponent in a simplified answer, so that would be 2 times 1 over x to the 4, or 2, just going to move that up a little tiny bit there. So that would be 2 over x to the 4. All right, so we'll try a few of the examples down below here. And the first one, you can use your power of a quotient rule, which would mean you'd square the top and you'd square the bottom, which would be x squared over 16. And this is as much as you can do with that, because there's no common factors that can cancel or anything. The next one is a power of a product, so you can bring that power inside to each part. So the negative 3 would get squared. The p cubed would get squared, and the t would be squared. So that would give you negative 3 squared would be 9. P cubed squared, you can power, you multiply the exponents, so that would p to the 6 and t squared. The next example, I see outside here the negative in the exponent. So I could flip the base and raise it to the positive, or another thing I can do is I could probably simplify what's inside the brackets first, and I think I'm going to do it that way this time. So this one, I would probably write that as x to the 5 times x cubed inside, because that's an x to the negative 3 in the denominator. So that means when you take the reciprocal of it, it eventually comes up in the top as x to the positive 3. So basically I've gotten rid of my denominator. So now I can add the exponents, and I get x to the 8 all to the negative 2, and then that would be x to the negative 16, which equals 1 over x to the 16. And there's always tons of different ways, it's for a lot of exponent questions, there's a lot of different ways you can do it depending on what you do first. So long as you follow the rules of exponents, you should get the same answer, because I think I did this one a little bit differently in class, and as well for one of the ones above. So you can see that I still get the same answer even though I've done it a different way. Because I've used the laws of exponents correctly, I should get the right answer. All right, so these ones here that have negative exponents in the numerator and denominator, but there's no addition or subtraction between terms, most times I try to avoid using the subtraction rule, the subtracting the exponents rule. So I would probably change this to leave the a squared where it is and the g squared where it is. But that g to the negative 3, when I take the reciprocal of that and raise it to the positive exponent, it basically brings it down in the bottom as g to the positive 3. And the a to the negative 4, when I flip that and raise it to the positive exponent, that's essentially bringing it up top as a to the positive 4. So now I would have a to the 2 plus 4 over g to the 3 plus 2, or a to the 6 over g to the 5. The next example, and again nothing can cancel there, so I leave that as that. The next one, I see that both of these have the same base. And they're power terms with the same base, so I can keep that base and add the exponents. So that would be negative 2 plus 4, which would become 3 over 4 squared, which becomes 3 squared, which is 9, over 4 squared, which is 16. And the next one, I have a power of a product and another power of a product, so I would bring that power inside to each part. So that would be a to the 4, all cubed, b to the negative 2, all cubed. Now, if you can do this step in your head without having to put those individual steps down, you can. And kind of skip to the next step I'm going to do after this line. So this would be, again, a to the negative 1, all to the negative 2, and b to the 5, all to the negative 2. Can't really squeeze that in there. So this would become a to the 12, b to the negative 6, a to the 2, because power of power, you're going to be multiplying these exponents, and b to the negative 10. And then you can add the exponents for the like terms because they're being multiplied, two power terms with like bases. So a to the 12 plus 2 would be 14, and b to the negative 6 plus 10 plus negative 10 would be negative 16. But again, you cannot have a negative exponent in a simplified answer, so you would write that as a to the 14 times 1 over b to the 16, which simplifies further to a to the 14 over b to the 16. And again, some of those steps can be skipped if you understand what you're doing. All right, so the next example kind of illustrates that a lot of times when we're given something that involves a lot of exponents and we're asked to evaluate it for certain values of x, we can plug the values in and work it out, which is sometimes is not too bad and sometimes is easier just to plug those values in and work it out. But if you've got to do an expression or evaluate expression for several different values, it can become tedious after a while. So sometimes it's a lot easier to simplify your expression first. So we're just going to show you how you can simplify an expression first before you start evaluating to get a simpler expression that you can plug values into. But we're going to do it 4 different ways just to show you that with the laws of exponents, there is not one set way to do them. The best way to learn the laws of exponents is to do the practice and correct your work. Check your answers when you do them in the practice in the book. Check your answers at the back to make sure they're right. If they're wrong, go back and see if you can find your mistake. And if you can't find your mistake, come ask me about it in class and we'll go over it so that you can figure out how to do these. Because again, you might see something a little bit different than I do and might not start it the same way, but we should all end up with the same answer if we've used exponent laws correctly. So if we look at the first one, we've got the expression that we have above, and this method here, they simplify what was inside the brackets first using their rule that when you have 2 power terms being divided by each other and they have the same base, you can subtract the exponents. So that leaves you with x to the 3 minus 2, or x to the 1. Oops. So that would be x to the 1, which is just x. You don't have to put that 1 there. And y to the 5 take away 7 is negative 2. And that's all going to be raised to the negative 2. So then what I would do there is I would go down one step further and use the power of a product rule. So that would be x to the 1 to the negative 2, and y to the negative 2 to the negative 2, which would give you x power of a power. Now you multiply and you get x to the negative 2, y to the 4. Okay? Some people will do the multiplication in their head and go from this step right to this step. That's fine. So then you'd have 1 over x squared times y to the 4. Because you can't have a negative exponent left in an answer that's simplified. So y to the 4 over x squared will be your answer. Okay, so the second method takes the exact same first expression, but this time it uses the rule for quotients first, and it takes the numerator and raises it to the power of negative 2, and the denominator and raises it to the power of negative 2. And then again, you would have to use your power of a product rule. So x cubed would get raised to the power of negative 2, and y to the 5th would get raised to the power of negative 2. And then in the bottom, x squared would get raised to the power of negative 2, and y to the 7 would get raised to the power of negative 2. Then you would have to use your power of a power rule, so that would be multiply the exponents, x to the negative 6, y to the negative 10, and this would be x to the negative 4, y to the negative 14. Now there is no addition or subtraction between the terms there, so I would just take anything that's a negative exponent in the top and put it down below as x, for example, x to the negative 6 is in the top, so that would come down to the bottom as x to the positive 6. And similarly, y to the negative 10 would come down below as y to the positive 10. And then the x to the negative 4 will come up the top as x to the positive 4. And the y to the negative 14 would come up the top as y to the positive 14. And then I would avoid using the subtraction law of exponents, but I would, for the quotient of power terms, I would cancel. I would say x to the power of 4 would cancel out with that x to the 6 in the bottom, leaving you with only an x squared in the bottom. And the y to the 10 would be cancelling with y to the 10 in the top, leaving you with only 4 y's multiplied by each other in the top. So you would be left with a y to the 4 over x squared, which is the exact same answer we got using the other method. So then the next example, we would have the rule here basically is to take this one. They've taken the negative exponent of 2 outside and dealt with that first. So they said negative in the exponent means flip the base. So they flipped the base and raised it to the power of the positive exponent 2. And then they approached similar to what we did in method 1 by subtracting the exponents and got x to the negative 1 and y to the 2 all squared, and then you'd have to use your power of a product rule, and that would be x to the negative 2 and y squared squared, which would be y to the 4. So that would be, again, 1 over x squared y to the 4, or y to the 4 over x squared. So you get the exact same answer, yet we started it a different way again, using a different exponent rule. And the final way, and this is not, there's probably other ways as well, but this is another way you can do it. Again, they flipped the base, dealt with the negative exponent on the outside and flipped the expression inside the brackets to the power of positive 2, but this time they used the quotient of powers, and they would wrote that the expression there was the numerator raised to the power of 2 and the denominator raised to the power of 2, and then apply the product rule. And then that would give you x to the 4, y to the 14, and x to the 6, y to the 10. And again, you can start cancelling again, so x to the 4 would leave you with x squared in the bottom when you cancel, and y 10th would cancel out 10 of those y's in the top, leaving you with a y to the 4 in the top. So you would be left with y to the 4 over x squared. So basically the little note down here just basically says that, again, there's several different ways you can simplify an expression involving exponents. Just make sure that you use your exponent laws correctly, and that your final answer does not contain any negative exponents. And the best way to learn how to simplify expressions using exponents is to practice, 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 and get those rules straight in your head. Okay, so page just has a few sample questions. So the first one here we have is 2 power terms being multiplied, and they both have the same base. So you can use your rule of adding the exponents. So 0.3 to the power of 4 plus negative 7, which would be 0.3 to the power of negative 3. Now I'm going to go a little bit further because I shouldn't have a negative exponent in my answer, but I don't like working with this decimal, so I'm going to change that to 3/10 to the positive. So we're still negative 3 because we're just replacing 0.3, to 3/10, so it's 3/10 to the negative 3. And then I'm going to apply my exponent rule, that negative in the exponent means to flip the base and raise it to the positive exponent. So that would become 10 cubed, or 1,000, over 3 cubed, which is 27. And the next one, I can use my power rule, my exponent rules, that I have two power terms being multiplied with the same base. So again, I can add the exponents in the top. So that would be 7 over 3 plus a negative 2 over 3. And then I can actually subtract the 1 over 3 from below. So that would give me 9 to the 7 over 3 minus 2 over 3 is going to be 5 over 3, minus another 1 over 3 is going to be 4 over 3. And there's not a whole lot I can do with that because I can't find the cube root of 9. Well, it asks you to write it as a single power, so that would be a single power. 9 to the 4 over 3. And this one would be a single power as well. I would accept both of these answers in number 1A, 10 over 3 to the 3, and 1,000 to the 27. 1,000 over 27. All right. So the next one asks you to write that as, simplify that as a single power term as well. So again, I'm looking at this power of power. I'm going to simplify that first. So that would be negative 2 over 3 to the negative 6. And then I'm going to divide that by negative 2 over 3 to the negative 20. And then I'm dividing two power terms with the same base, so I can subtract the exponents. In this case here, I would use subtracting the exponents, negative 6 minus a negative 20. Just be careful though, because you're subtracting a negative, so that becomes the same as negative 6 plus 20. And that looks like a 6 there, sorry. So this would become negative 2/3 to the negative 6 plus 20 would be 14. And then that would become, well, you're asked to actually leave it as a single power term, so we don't actually have to evaluate that any further because that is a single power term. Okay, question 2 asks you to simplify each of these expressions. So the first one, I would just put my like power terms together, my two power terms with the same base, so it would be x to the 5 plus a negative 5, or 5 minus 5, and y to the negative 3 plus 7. So that's going to be x to the 5 minus 5, which is 0, y to the 4. And that would be x to the 0 would become 1 times y to the 4, which would just be y to the 4. In the next example, we have, I would, before I start cancelling things, I would get those negative exponents out of the numerator and denominator. So I would leave the 8 and the a cube where they are. I would bring that, leave the 12 and the b to the 5 where they are. But I would take that b squared that's in the top, b to the negative 2 in the top, and put it down as a b squared in the bottom. And it would take that a to the negative 3 that's in the bottom and bring it up top as an a to the positive 3. And then I would start putting my terms together and cancelling things. So I'm just going to go 8a to the 3 plus 3 is going to be 6. And then 12b to the 5 plus 2 is going to be 7. And then there's one more thing I can do, because 8 and 12 have a common factor of 4. 4 goes into that twice, and then it goes into that 3 times. So that would leave me with 2a to the 6th over 3b to the 7. And the next example, I would do my power of a product first, 2m, and then that would become 3 squared, m to the 4 squared, which is m to the 8th. And I'm skipping some steps now because you shouldn't have to put all the steps there all the time. You should be able to do some of that multiplication in your head. And then this would be 6m, n cubed. And I'm just going to simplify that a little bit more. 2m to the 9. Because the m's would get multiplied. And I have times 9 n squared. So I put the powers of m together, and I got 9n squared still, because the 3 squared was a 9. And then in the bottom I have 6m n cubed. So that's going to give me 18 m to the 9 n squared. So just multiply the 2 and the 9 together, get 18, and I got my m to the 9 and my n squared, and then I've got 6 mn cubed in the bottom. And then that 6 can go into the 18 3 times, and I can cancel one of those m's. So I have 3m to the 8th, and I can cancel, that would be m to the 8th, and then I can cancel that n squared with the 2 of those n's in the bottom, leaving you with just an n in the bottom. All right, question number 3. Just move that up a little bit. Okay, question number 3. There's a couple of different things you could do here. I think in the first one here I'm going to simplify inside the brackets first, deal with that half outside later. So I'm looking at that and I'm just going to cancel. 2 goes into 50 25 times. Then the x squared can cancel out 2 of those x's in the bottom, leaving you with only an x squared in the bottom. And the y to the 4 can cancel out 4 of those y's in the bottom, leaving you with just a y cubed in the bottom. So I would have 25 over x squared y cubed, all to the half. Can I just rewrite that again, because it's kind of squished in there. So that would be 25, sorry. Nothing else left in the top but 25, and in the bottom we had an x squared and a y cubed. And all that would be raised to the power of a half, which means basically the square root of, so 25 to the half, and then x squared y cubed to the half, which is going to be, the square root of 25 is 5, because 25 to the half means square root of 25. And then you'd have x squared to the half, which would just be x squared, x to the 2 times a half, which would be x to the 1, and y to the 3 over 2. In the next example, I would cancel that 3 and 12 right away there, and I would move my x's that are negative powers down the bottom and y's that are negative powers, y that's a negative power up on the top. So my y to the 5 over 2 would stay up in the top, but my x to the 5, x to the negative 5 will come down as an x to 5 in the bottom. I still have the x to the half down in the bottom, and that y to the negative a half, I would move that up top as y to the positive a half. So basically the y to the 5 over 2 stayed where it was. That concept looks like an x there, doesn't it? And the x to the half stayed where it was, but the y to the negative half moved up top as y to the positive half, and the x to the negative 5 moved down below as x to the positive 5. So then I can start putting like terms together, putting the power terms, I should say, with like bases together. So this would be 4 to the y, 4 times y to the 5 over 2 plus 1 over 2 is going to be 6 over 2, or 3. And then x to the 5 plus a half, well 5 is 10 over 2, plus a half. So that would be 4y cubed over x to the 11 over 2. And there's not really a whole lot more I can do with that. And the next example there would be, I can basically get rid of those brackets because there's no powers outside, so I can add the exponents 3 plus negative 1, and the y to the negative 3 over 2 plus a half. So that would equal x to the 2 and y to the negative 2 over 2, which would be x squared y. Try that again. Y to the negative 1, which would be x squared times 1 over y, or x squared over y. Okay, so this example here now is finding the errors in a given solution. So if we look at the first one there, if we start to do our own solution, we have a to the negative, keep touching those buttons, a to the negative 4 to the negative 1, b to the 5 to the negative 1 over ab to the 5. So if we work that out, that should actually be a to the 4, not negative 4, and b to the negative 5, not add the exponents, I have to multiply them. So then that would be over a b to the 5, and then I would move that b to the negative 5 down below, so I'd have a to the 4, a, and then a b to the 5, and then the b to 5 that was already there, and then that would, the a's can cancel, leaving me with a cubed in the top, and the b to the 5 times b to the 5, I can add those exponents and get 10. The next example, again, is same kind of error, because when you have a power of a product like that, you would be multiplying 3 over 2 by the 1 over 2, which would give you 3 over 4, not 2. And 3 over 2, which should get multiplied by the 3 over 2, which should give you 9 over 4, not 3. And similarly here, it looks like they added 2 and negative 1 instead of multiplied 2 and negative 1. This here should be k to the negative 2, and this should be h, this one's okay, h to the negative 1. So what we would do here is k to the half should get raised to the power of 3 over 2. And I got to erase all this here because I can't really see what I've got. So k to the half would get raised to the power of 3 over 2. And h to the 3 over 2 would get raised to the power of 3 over 2. And then k squared would get raised to the power of negative 1. And then h would get raised to the power of negative 1. So that would give you k to the 3 over 4, h to the 9 over 4, k to the negative 2, h to the negative, I'm going to use that negative there, 1. And then I can add the exponents, so k to the 3 over 4 minus 2, plus a negative 2, right? H to the 9 over 4 minus 1, because plus a negative 1 would be minus. So then that would be k to the 3 over 4 minus 8 over 4, because if I put 2 over 1, because that 2, if I want to add 3 over 4 and negative 2, I can get a common denominator, so 2 would become 8 over 4, 2 over 1, multiply top and bottom by 4, and then h would be 9 over 4 minus 1 as with a common denominator 4 would be 4 over 4. So that would give you k to the negative 5 over 4 and h to the 5 over 4, which I would go one step further and write as h to the 5 over 4 over k to the 5 over 4, because k to the negative 5 over 4 would be 1 over k to the 5 over 4. All right, so the next question asks you to look at the errors. 3 people tried to evaluate this, and these were 3 errors. So you're trying to evaluate 2 to the negative 2 over 3 times 2 to the 0. So it looks like Bobby multiplied the 2 by the 2. Can't do that. I'm not sure what he did with the exponents, but you can't multiply the bases. Like that. Charlie kept the base, but he didn't add negative 2/3 and 0 is not negative 1/3. Because you're supposed to add the exponents there when you have the same base. And again, looks like Michael multiplied the bases and got 4 and multiplied the exponents and got 0. So multiply, can't multiply bases and exponents. That looks like what he did wrong. So the correct answer would be 2 to the negative 2/3, and if you want plus 0, or you can say 2 to the 0 is 1, whatever you want to do. Either way you can look at it. So that would be 2 to the negative 2/3, which is 1 over 2 to the 2/3. So you can't really, that would be the cube root of 2 squared, which isn't a really nice number. So that's as much as I would probably do there, unless you want to use your calculator to evaluate it approximately. Okay, so this page here just basically talks about how you can use exponent laws to help you solving equations. So we're not going to do a whole lot with this. It's just kind of just telling you some things you can do. You'll be using this probably in some of your later math courses, depending on which program you follow. So if you're looking for example, to solve the square root of 5, square root of x, equals 5, you can square both sides to get the answer, or you can think of it as square root of 5 as x to the half using exponents, and then basically what you do is you raise both sides to a power that will give you x to the exponent 1. So basically you'd be raising both sides to the reciprocal of that exponent, and then will give you x equals 25. And similarly, if you had something like x cubed equals 24, you could basically, what you want to get is x, not x cubed, so you'd raise both sides to the power of a third, because 3 times a third would give you 1 when you're using your power over power rule, multiplying the exponents. So then x would give you 24 to the 1/3, which is the same as the cube root of 24. The last example here just shows you how you can just evaluate questions, evaluate using formulas that have exponents in them. So they give you a volume of a sphere is 4/3 pi r cubed. That's the formula. So they want you to substitute in 5.964 for the volume and work out what the radius would be. Now, seeing that this is in decimals, the volume is in decimals, I'm going to change the 4/3 pi to a decimal as well. So that would be 4 times pi divided by 3, and that works out to be 1.18879, some more decimal places, that's enough, r cubed. And if I want to get r cubed by itself, so I want to isolate the r cubed, so I would divide both sides by 4.18879. Because that would cancel on this side, and I would be left with, on this side, I would be left with r cubed, and on this side, I would have 5.964 divided by 4.18879, and that would give me 1.4238. So if I wanted to find r, I could raise both sides to the power of a third. And that would give me r to the power of 1, or r. And then you can just put that in your calculator, to the power of bracket 1 divided by 3, bracket, or cube root, whichever one you want to use. And I would get 1.12499, so approximately, doesn't say to the nearest thousand, is it? Nearest thousand would be 3 decimal places, so we would have 1.12499 1, 2, 5 inches. And there's some questions there at the bottom that you can try to practice some of the topics that we learned in this section.